Hello, welcome back once again. Today we have this interesting integral. And today we have a definite integral, right? The integral from 0 to pi all over 2, the sine of x to the power of k divided by the sine of x to the power of k plus the cosine of x to the power of k dx for all k. Can we solve this problem? Let's see how we're going to solve this problem, okay? So in this video, we're going to make use of the so-called King's property. Here is the property. We have the integral from a to b of a function of x dx. So according to the King's property, this is same as the integral from a to b of f of, here we have the sum a plus b minus x then dx, okay? So this right over here is called the King's property. Okay, so we're going to use this to solve this problem. So we know we have a plus b. So our own here, we have the lower limit or the lower boundary, which is 0, and the upper boundary, which is pi all over 2. Therefore, their sum will be pi all over 2. Then let's call this integral I. Okay, so using the King's property, we already have our I. Our I is equal to the integral from 0 to pi all over 2, the sine of x to the power of k divided by the sine of x to the power of k plus the cosine of x to the power of k dx, right? So according to the King's property, so our I is same as the integral from 0 to pi over 2. Then here we're going to have the sine of pi over 2 minus x to the power of k divided by the sine of pi over 2 minus x to the power of k plus the cosine of pi over 2 minus x to the power of k dx. Okay, so let's take note of the following. We have that the sine of the angle pi over 2 minus x will give us the cosine of x, right? And we also have the cosine of the angle pi over 2 minus x will give us the sine of x. Okay, so using this idea now, our I will be equal to so sorry for that. So our I will be equal to the integral from 0 to pi over 2. So up here we have the sine of pi over 2 minus x to the power of k, which is same as the cosine, right? Yes, so the cosine of x to the power of k. Then divided by, here will be the cosine of x to the power of k, plus here, this one here will be the sine of x to the power of k, right? So we have sine of x to the power of k, and we have our dx. Okay, now what are we going to do next? So let us go back and take note of the following. We know this here is same as I, right? So let's sum the two integrals. Okay, so we're going to have here I plus I will be equal to the integral from 0 to pi over 2. So the first one there, we have sine of x to the power of k divided by the cosine of x to the power of k plus the sine of x to the power of k dx. So plus the second one here is this one right over here. So we have here the integral from 0 to pi over 2. So up we have cosine of x to the power of k, then divided by the cosine of x to the power of k plus the sine of x to the power of k, and we have our dx. Okay, so take note that we have the same denominators, right? So at the left hand side we then have our 2I. So this will be equal to the integral from 0 to pi over 2. Since we have the same denominator, so we can add the numerators from here. Okay, so we're going to have up there the sine of x to the power of k plus the cosine of x to the power of k, then divided by, we choose any of the denominators since they are the same, right? So that will be, let's rewrite it as just the sine of x to the power of k plus the cosine of x to the power of k, and we have our dx. But there's a miracle here. Can you guess? This here is equal to 1, right? So we have 2I is equal to the integral from 0 to pi over 2. So we just have 1 times the x, which is the x. So this is equal to the integral of 1 with respect to x, which just give us x. And we have our limit from 0 to pi over 2, right? So let us put the upper limit first. So we get pi over 2 minus the lower limit, which is 0. So this will give us pi over 2. So now from here, do not forget that our 2i right now is equal to pi over 2, right? So divide both sides by 2 just to get our I, right? So once you do that, you get that I is equal to pi over 2 divided by 2, which will give us pi over 4. Awesome, right? Wow. So this is exactly equal to the integral from 0 to pi over 2 of sine of x to the power of k divided by the sine of x to the power of k plus the cosine of x to the power of k dx. And this here is our solution. Thank you for watching. Please, if you really enjoy my videos, do something very nice for me. Please kindly support my channel by subscribing. Please do not forget to subscribe to this channel. Turn on the notification bell so that you'll be notified whenever I upload new videos. Bye.